All right, so now we will actually begin graphing using the equation of a line. So we have graphed using t-charts and finding x-y pairs and graphing the points and then drawing the line, but today we're going to look at actually using the equation of a line to know how to graph that line. So specifically, equations need to be in a form that's called slope-intercept form, which is why this section of notes is called slope-intercept form. So let's take a look at that. So slope-intercept form is the form of equation that looks like this: y equals mx plus b. Now y and x are just y and x. M, so this number here, this is the slope, which if you remember from last time, is a number that tells you how steep and what direction the line goes. And b here, this is the y-intercept. So the y-intercept is the point where the line crosses the y-axis. So using these two numbers, we can know exactly where the line goes and what angle it goes through that point. So let's try it. Example A says we're going to graph the following lines. Example A says y equals 1/2 x plus 5. So we know the slope right here is 1/2, and we know the y-intercept is 5. And so what we do, the y-intercept means that is where the line crosses the y-axis. So we go to 5 on the y-axis, which remember is the up and down axis. So right here, the slope is 1/2. So remember that's up 1, right 2. Since it's positive, it's going up to the right. So up 1/2 from that point on the y-axis. And you want to do that over and over, up 1/2, over and over, okay, until you get to the edge of the graph. Then you want to go back to the middle and go backwards, down 1, left 2, keeping a straight line there, just so it's nice and easy to go through all the points like that. And there you have it. So from 5 on the y-axis, up 1/2, over and over and over, until you can make a nice straight line. Let's go on to example B. The slope here, right here on x, is -3/2. And the intercept is -1. Make sure those negative signs stay with those numbers. And this is why when we were solving for y, I said you want to put the x term first, because that is your slope, and it should come first in slope-intercept form. All right, so we start at -1 on the y-axis. That's right here, down 1. The slope is -3/2, so down 3, right 2 brings you right here. And since it's negative, we could put this negative sign on either number, but I always recommend just keeping it with the top number. So you're going to go up or down, and then always to the right. So down 3, right 2. The exception there is when you go backwards, up 3, left 2. But if you get the initial direction the same, then going backwards is just doing the opposite of whatever you did before. So we started out going down 3, right 2, and then the opposite is just up and left. And then draw the line. Connect those dots. Example C, y equals 3x minus 2. Your slope here is 3. The intercept is -2. Now, when you have a whole number like this, you want to think of that as 3/1. So we're going to go up 3, right 1, since every whole number is just a fraction over 1. Intercept is -2, so down 2 on the y-axis. The slope is 3/1, so up 3/1 to the right, up 3, right 1. Do that over and over and over until you can't do it anymore. Go back and go backwards, down 3, left 1. And then we can connect these dots for the line. The more dots you have, the easier it is to draw a straight line across the whole graph. And you do really want to get in the habit of drawing the line across the whole graph. If you just do something like this, if you go -2 and then up 3/1, you can, that's the line, right? But there are certain things we'll be doing later on where you're going to want the line across the whole graph. So if this is all you have, it's not really giving you a complete picture of what the line looks across the entire graph. So it's a good habit to get into, just to go all the way across whatever size coordinate plane you have in front of you. All right, next example, slope is -2, or remember -2 over 1. And the intercept here is 3. So we go to 3 on the y-axis, positive 3, and then down 2 over 1, down 2 over 1, over and over and over, down 2 over 1, and then up 2, left 1. Keep the same line, and then connect. Again, you want to go across the whole graph. If I'm going too fast, feel free just to pause the video until you get the line drawn. Okay, next, y equals x minus 4. So the slope here, in front of x, we have a 1 that you don't have to write, and that's 1 over 1, if you want to put it over 1 there. The intercept is -4. Make sure the negative sign stays with it. So we start at -4 on the y-axis. We go up 1 over 1, so just like this. And then you can connect those dots. All right, example F. Y equals 2x. Now this is sort of a special case where we don't have a number here. Right? We know the slope is 2 still, or 2 over 1. And there's a plus 0 here that we don't have to write because it doesn't change anything. So the intercept here is actually 0 because, again, there's a plus 0 that doesn't have to be written in the equation. So we start at the origin and then just up 2 over 1. So when you don't have an intercept, a b value in the equation, you know that's because it is a 0. So through the origin, up 2 over 1, and then backwards down 2, left 1. Let's go on to the next example. Y equals -3. Now here, there's no x, right? We have a number, but there's no x. And that's because there is a 0x right there that we don't have to write, which means our slope here is 0. The intercept is -3. And remember, a 0 slope looks like a horizontal line, right? So at -3 on the y-axis, we're going to have a horizontal line. So that's sort of a special case. So whenever you have y equals a number, it's going to be a horizontal line through that number on the y-axis. Because there's a 0x where the slope should be, there's a 0 that you don't have to write. Now, the other special case we have is when it's x equals a number. Now, this is sort of the only type of equation of a line that does not follow slope-intercept form. Because remember, slope-intercept form is y equals mx plus b. Well, we don't even have a y value here. We have an x value. And if we were going to get that into slope-intercept form, well, we really couldn't. There's no y. And so what this looks like, when you have y equals a number, like example G, it's a horizontal line. And so the opposite of that, sort of I guess not opposite, but the other hand of that, the other side of that, is x equals a number, which is going to be a vertical line through that number on the x-axis. So it's a little different. It doesn't follow the same rules when x equals a number. The slope here, there is no slope. No slope, because vertical lines have no slope. And for the y-intercept, well, let's look at it. X equals 5. We go through 5 on the x-axis vertically. And this line does not have a y-intercept. It never crosses the y-axis because it's going vertical over here next to it. So there is no y-intercept either. So when x equals a number, you don't have a slope and you don't have a y-intercept. You just have a vertical line through that number on the x-axis. And again, that's the only kind of equation here that does not follow the same form as the others, and so you kind of know when you see it that it's a special case. Okay, so there you have it. Graphing with slope-intercept form. Start with the intercept, the b value. Use the slope, the m value, to go to the next point. Plot all the points across the graph, and then draw the line.